Hello mathematicians, we're now going to start a review of known functions and relations. I realise after our little survey today that these may not all be known, but I'm thinking the first few should be. So I'll skip through these fairly quickly and then slow down for some of the later ones. So the first thing that we have a look at is linear functions. The straight line graph, which is what a linear function is, has this equation, ax plus by plus c equals 0, if it's written in standard form. Now it's important to note that the a will be a positive number just here. If possible, a positive integer. So this layout here is how it will often be quoted in textbooks, in exams, etc. It may not be the format that you're most familiar with. You may be more familiar with y equals mx plus b. But of course, they're just rearrangements of the same thing. So if we make y the subject of this equation, what we can get is, if we take the ax over, take the c over, and then divide through by b, we get this, y equals minus a on bx plus minus c on b. So that means that minus a on b from standard form is the gradient, and minus c on b from standard form is the y-intercept. So what we hopefully can do is look at an equation in either form and straight down work out its gradient and y-intercept. So if we had y equals 3x plus 2, for example, we look at it, gradient 3, y-intercept 2. If we had 4x minus y plus 6 equals 0, we look at it and we see that the gradient is minus a on b, so that's 4 on minus 1, which is 4. And the y-intercept is minus c on b, which is minus 6 on minus 1, which is going to be 6. Just a small note, that's often written as, in the rest of the world basically, as the letter C, but it makes no difference as long as you know they're talking about the y-intercept. Now, if you're not comfortable with this second step, just make y the subject of the equation. It's only one more step, and use what you're familiar with. Now, moving on to sketch a straight line function. If we can locate 2 points, that's enough to sketch the function. So, if we can find the y-intercept by putting x equals 0 and solving the equation, and the x-intercept by putting y equals 0 and solving the equation, that's enough. So again, if we just glance back at this one, 4x minus y plus 6 equals 0, if we put x equals 0, that gives us y equals 6. So that's our y-intercept. If we put y equals 0, that gives us 4x plus 6 equals 0. So 4x equals minus 6, x equals minus 6 on 4, or minus 3 on 2. So that will be our x-intercept. And with those 2 points, so that's the point 0, 6, and the point minus 3 on 2, 0, that's sufficient for us to plot the point. In terms of stuff that we've looked at yesterday, or today, the domain of the straight line is all x, all real x. This is just it written with a fancy R. The range is all real y. However, if a or b are 0, so that's the coefficient of the x or the coefficient of the y, we have some special cases. So, for example, if x was 0, we would just have by plus c equals 0, or in other words, b equals minus c on, y equals minus c on b. Now, this bit's unimportant except for the fact that it's a constant, and y equals a constant is some horizontal line. Similarly, if y is 0, then we're going to get x equals a constant, which is some vertical line. So in those cases, obviously in this one, we have a domain which is all real x and a range which is just whatever the value of y is. For this one, we have a domain which is just whatever the value of x is and a range which is all real y. But there are obviously two exceptions. Now I'll just have a quick look at the GeoGebra. So if we look at this line here, we have a rise of 4 and a run of 2, so that gives us a slope of 2, cutting through the y-axis at 0, so our equation is just y equals 2x, and in standard form it's 2x minus y equals 0. I can't get rid of all of these oddities on this program. So if I increase the value of c, what does that do? Well, as we expect, we take the line up or down, but we don't change the value of the slope. The slope only depends on the relative values of a and b. So if I made them equal to each other, a equals 1 and b equals 1, I get a line with a slope of minus 1. If I make them same size but opposite magnitude, I get a line with a slope of plus 1. If I set b equal to 0, I get the vertical line with an infinite slope, and if I set a equal to 0, I get a horizontal line with a slope of 0. Now hopefully all that is familiar, but you may need to write yourself down a little bit of a summary of all of those things. Let's have a quick look at these examples. I'll start from this end because they're easier. So the line x equals minus 3 is going to be a vertical line cutting through minus 3. I won't label on all of them, y and x. The line y equals 2, a horizontal line cutting through 2. This line here, x plus 2y equals 0. Either we will make y the subject, so that would become y equals minus x on 2, so a gradient of minus a half, which means it passes through the origin, and if we go 2 this way, we'll go 1 up there, so we're at negative 2 and 1. Or we use our alternate, because this is written in standard form, gradient is minus a over b, so that's minus 1 over 2, as we said. And for the first one, x plus 2y equals 6, again, use whichever option suits. Whichever way we go, we're going to have to alter this equation. So if I go in standard form, it will be x plus 2y minus 6 equals 0. So my y-intercept is minus c over b, so that's minus 6 over 2, so that's 3. And my gradient is minus a over b, so again that's minus a half. The easiest way to plot it though is to say we cut the x-axis when y equals 0, so that's going to be when x equals 6, and we cut the y-axis, of course, when x equals 0. So that will be at 2y equals 6, y equals 3.